Good morning, boys and girls. We're just going to do a quick review of logarithmic functions and how to convert from log to exponential and exponential to log. So let's begin by just identifying what an exponential function looks like. So we see here y equals a to the bx. This is an exponential function. And the reason what makes it exponential is this b to the x. When you have a constant, b is a constant, and x is going to be your variable. So what we're saying is that anytime we have a constant raised to a variable, well, I should say that. B, there's some restrictions on b. B has to be between 0 and 1, or b can be greater than 1. B cannot equal to 1, and b can't be negative. So when we have an expression in this form, it's exponential. And so the domain of a basic exponential function, now we can translate it, but we would never change its domain. Its domain will always be negative infinity to infinity. Those are all the values of x that will work in this function. The range can be manipulated if we translate it, but for a general function, the range would be from 0 to infinity. And what I want you to notice that 0 is not included, and I'll show you why in a moment. So here we have some examples of exponential functions. So notice each time we have a constant being raised to an x power, and that makes it exponential. Looking at these graphs, we see this is a basic exponential function. Notice its domain is negative infinity to infinity because it goes on in both directions. But notice its range is from 0 to infinity because it's never going to touch that x-axis. So it doesn't touch that x-axis, but it goes forward. If we look at this problem, we'll see that this has been translated up 3 units. So now our domain is still what? Yes, you're correct, negative infinity to infinity, but the range is from 3 to infinity. And notice 3 is still not included because it's never going to touch 3. This is a exponential function that is reflected over the x-axis, but nonetheless, its domain is still negative infinity to infinity, and its range is now from negative infinity to 0. So notice the range changes, but the domain remains the same in all exponential functions. So if we want to graph an exponential function, in your calculator, you would put in y1, you would put y equals 2 and put the little caret button, x. And then we've done these in class. You go to your table and you get your values. And what we see, let's just kind of plot a few values here. When x is 4, y is 16. When x is 2, y is 4, so x is 2, and y is 4. When x is 1, y is 2. So notice how it's increasing. And then we can plot these small values. When x is 0, y is 1. And then the values are just getting smaller and smaller and smaller, closer to x, but never really touching x. And so we can see this is an exponential function. Now, what I wanted to remind you of, when b is greater than 1, like we talked about up here, when b is greater than 1, our exponential function is increasing. So we can see that in this graph. So b is 2, so the function, well, you can't see that now, can you? So b is 2, so the function is increasing, and we see that as we graph it. So what do you think is going to happen when we have b of 1/2? Well, when b is between 0 and 1, our function is now decreasing. And we'll see that when we graph it using the points. Once again, I put these in the calculator to get my points. So now at -4, I'm at 16. At -2, I'm at 4. At -1, I'm at 2. At 0, I'm at 1. So we can see, and then it gets smaller and smaller and smaller, closer to that x-axis, but never touching that x-axis. So we can see that this is a decreasing function. Okay? Now, the inverse, the inverse of an exponential function is a logarithmic function. We mostly times just call it a log function. And it's written in the form y equals log base b of x. So this is the base that we had in our exponential. That base is the same. And the restrictions for that base remain the same. So because log and exponential functions are inverses of each other, their domain and their range switch. So now the domain of the exponential function was -infinity to infinity. So now that's going to be the range of the log function. The range of the exponential function was 0 to infinity, so that becomes the range of our logarithmic function. And here are examples of logarithmic functions. That's what they look like. And if we were to graph it, we would see that the functions above also will appear like that when we graph them in log function. Okay, so that's it for this video. Come back in a minute and we'll convert from log to exponential form.